So, our topic for today is about wave interference. Waves are existent in our surroundings. It could be in many different forms and mediums. So, as you could see from here, 'di ba, ang mga samples natin ng waves are the water waves, 'di ba? The seismic waves, the sound waves, light waves, electromagnetic waves, and many more. So these waves are in different form as well as iba-iba rin yung medium kung saan dumaloy or nag-travel yung wave. So dahil ang wave is not a matter, it has no physical body, so wave cannot be destroyed. But it could be transferred or transformed, diba? Many of those various wave phenomena require two or more waves passing through the same region of space at the same space and time. Actually, most of the waves naman talaga, hindi lang iisa yung nagta-travel. Talagang marami, 'di ba? Napakaraming waves ang nagta-travel in a single a small fraction of time. And most of them then ay nagkakaroon ng collision with each other or nagkakaroon ng interaction with each other. And with that, nagkakaroon ng transformation with its formation. Not necessarily na nabago yung wave. For example, hindi naman to nabago from light wave to sound wave agad. 'Di ba? Nag-iba lang yung formation or yung shape ng wave. And kasi kapag nag-iba yung shape ng wave, naapektuhan yung mga factors nito. Like amplitude or frequency and others. So ang tawag natin sa interactions na yon or sa collisions na yon is what we call interference. Okay. So we will tackle the first interference, the constructive interference. So according to the figure, if two traveling waves meet, diba, and pass through each other without being destroyed or even altered, it combines, adds, and become one. Okay. So as you could see from the GIF, diba, nagkaroon ng collision between the two waves. Hindi naman siya nasira, 'di ba? Pero nagbago yung form nila at nag-add sila sa isa't isa. Ayun, kaya mas lumaki yung wave nung nag-collide ang mga ito. So ang tawag natin doon is constructive interference. So as you could see from the video, 'di ba? Yung droplets, 'yan ay tumulo sa water system. Ito yung water system natin. So then nagkaroon ng expansion of circular waves nung tumulo or tumama yung droplets dun sa water. Ngayon, as you could observe, 'di ba? Yung mga ripples o yung mga waves ay nag-pass through each other lang. Hindi huminto, hindi bumilis, 'di ba? Hindi nabago yung shapes nung mga una, pero nadagdagan, 'di ba? As you could see, kapag pagkatama ng dalawang waves to each other, magkakaroon ng panibagong wave. Kaya parang tatlo na yung naging ripples instead of dalawa na lang as it expands. So in the region of overlap, the resultant wave is found by the adding by adding the displacement of the individual waves. So this is a sample of constructive interference. For such analysis, the superposition principles applies. Okay. When two or more traveling waves encounter each other while moving through a medium, the resultant wave is found by adding together the displacements of the individual waves point by point. Waves overlapping and coming together like that is called constructive interference. So, ulitin ko lang, the principle that lies behind the constructive interference is what we call superposition principle. Okay. So, this explanation explains the constructive interference, kung ano yung nangyari sa past slides natin. Next, two similar inverted waves traveling directed to each other. So kung makita nyo sa picture, di ba? Dalawang waves yung nagta-travel pero magkaiba sila ng position. For example, yung first wave is in the Y positive, meanwhile the second wave is in the Y negative. Okay? Now, nung nag-travel sila to each other, nag-pass through na sila to each other, the same pa rin. Di ba? Yung position. Ganun pa rin sila. Walang nagbago. Gets po ba? Yun. The first wave is still in the Y positive, meanwhile the second wave is in the Y negative. The resultant wave shown in figure C, this is the figure C, results in a wave with flattened amplitude. Okay? So if these were water waves coming together, one of the waves would exert an upward force on an individual drop of water. At the same instant, the other wave was exerting a downward force. So kung makikita nyo dito, kagaya na in-explain ko kanina, 'di ba? Merong magkasalubong na magka-opposite na wave. Ngayon, nung nagsalubong sila, to the point of collision, 'di ba? Magfa-flat yung wave. Okay, mawawala yung wave. Okay. Ayun. Visible siya dun sa figure C. Ngayon, pag nag-pass through na sila to each other, which is in the figure D, babalik sila with their original positions. Okay? So, parang nag-pass through lang talaga. Tapos, bumalik na with the original position, which is opposite direction yung wave. So, the result would be no motion of the water at all. In such a situation of the two waves are said to be 180-degree out of phase and to exhibit destructive interference. So, ang tawag natin dito sa wave na to is destructive interference.